Imagine standing on Earth after 75% of species vanish. That happened 66 million years ago, in less than a few thousand years. An asteroid over 10 kilometers wide hit with the energy of 10 billion atomic bombs. Forests burned, oceans acidified, food webs snapped. For dinosaurs, it was the end. But for life itself, it was a starting gun. Within just 1 million years, an eye blink in geological time, survivors began changing at speeds that still unsettle biologists. Mammals that once weighed less than a house cat ballooned to the size of bears. Birds lost teeth, gained new flight styles, and rewired their brains. Fish developed crushing jaws powerful enough to shatter shells like ceramic plates. Think about that timescale. 1 million years is shorter than the time between the pyramids and today, if human history were stretched to match Earth's. And in that compressed window, evolution didn't just recover. It experimented, aggressively, recklessly. Traits appeared that had never existed before and in some cases never appeared again. Bone-crushing teeth, armor-plated mammals. Predators that hunted like reptiles but breathed like birds. Herbivores that ran on tiptoes. Brains that tripled in size without warning. Today, we're exploring what happened after the extinction. When the usual evolutionary rules loosened, competition vanished, and life pushed itself to extremes. The mystery isn't why species survived. The mystery is why evolution went so far. After a mass extinction, the most important thing is not what survives, it's what disappears. 66 million years ago, the asteroid impact erased entire categories of life. Not just species, but roles, apex predators, large herbivores, specialized feeders. In ecological terms, Earth didn't just lose animals, it lost structure. Imagine a modern city where every large vehicle vanishes overnight. No trucks, no buses, no cargo ships. The roads are still there, the fuel still exists, but the entire system breaks, and then something new rushes in to replace it. That's what happened after the dinosaurs. Before the impact, mammals were small, mostly nocturnal, rarely heavier than a few kilograms, about the weight of a house cat. Dinosaurs occupied nearly every large-bodied niche on land. Birds filled the skies. Reptiles dominated warm ecosystems. Mammals were constrained, not because they lacked potential, but because there was nowhere to go. Then suddenly, there was everywhere to go. This phenomenon has a name: ecological release. When dominant competitors vanish, surviving lineages experience a dramatic relaxation of constraints. Traits that were once liabilities become advantages. Growth accelerates, body plans diversify, evolutionary experimentation intensifies. The fossil record shows this clearly. In the first 500,000 to 1 million years after the extinction, mammal body size increased by up to 100 times. That's not a gradual trend. That's a biological explosion. To put that in perspective, a modern mouse evolving into something the size of a rhinoceros in a time span shorter than human civilization has existed. Why so fast? Because evolution runs on opportunity. And after the extinction, opportunity was unlimited. Plants recovered first, spreading rapidly across burned landscapes. Insects followed, then small vertebrates. But with no large herbivores to control vegetation, plants grew denser and tougher. That selected for animals with stronger jaws, better digestion, and larger bodies. Larger bodies, in turn, required more food, driving further adaptations. It became a feedback loop. Predators evolved next. With no tyrannosaurs or dromaeosaurs left, the pressure to stay small disappeared. Mammals that once hunted insects began hunting other mammals. Speed increased. Teeth sharpened. Brain regions associated with smell and coordination expanded. And all of this happened in ecosystems that were unstable, chaotic, and constantly reshuffling. Here's where it gets strange. Normally, evolution is conservative. Drastic changes are risky. Most extreme mutations fail. But after a mass extinction, failure becomes cheap. When competitors are gone and niches are empty, even inefficient or awkward designs can survive long enough to reproduce. Evolution doesn't aim for perfection. It explores. The result is a period scientists sometimes call evolutionary excess, a burst of forms that push anatomy, size, and behavior beyond what would normally be sustainable. Many of these forms would not last. Some persisted for a few million years. Others vanished almost as quickly as they appeared. But during this window, Earth became a testing ground. And the fossils from this period, compressed into thin rock layers, show animals that look almost unbelievable. Creatures that seem overbuilt, overarmed, overgrown, which raises the next question. What exactly did evolution build when nothing was stopping it? 1 million years after the extinction, the planet is unrecognizable. This is where the fossil record stops looking cautious and starts looking reckless. In what is now New Mexico, paleontologists uncover the skull of Pantalambda. It lived just a few million years after the dinosaurs disappeared. Its body mass approached 100 kilograms, roughly the weight of a large motorcycle, making it one of the first truly large mammals in Earth's history. Its teeth are thick and blunt, built not for speed but for crushing. This is not a transitional animal. This is a statement, and it wasn't alone. Across North America and Asia, mammals began splitting into wildly different forms. Some developed elongated limbs for running in open landscapes. Others grew dense, barrel-shaped bodies and short legs, trading speed for power. Herbivores experimented with enlarged guts and reinforced rib cages, allowing them to extract nutrients from tougher post-extinction plants. Then there were the predators. Mesonyx, an early carnivorous mammal, hunted on long legs with blade-like teeth. It looked vaguely like a wolf, but it wasn't closely related. Its skull mechanics suggest a bite strong enough to shear flesh, but not optimized for endurance. This was evolution trying out a new predator design from scratch. Here's the moment that makes scientists stop and stare. Within just a few million years, mammals evolved bone-crushing jaws, something no dinosaur ever perfected. Later descendants, like Andrewsarchus, would carry skulls over 1 meter long, the length of a baseball bat plus your forearm. The estimated bite force rivals that of modern crocodiles. A comparison helps. A modern human jaw can exert roughly 70 kilograms of force. Large crocodilians exceed 1,600 kilograms. Andrewsarchus lived closer to the crocodile end of that spectrum. If you had placed your arm between its jaws, bone failure would occur almost instantly. Not from teeth piercing flesh, but from raw compressive force. This is not just a bigger animal. This is a fundamentally different use of anatomy. And mammals weren't the only ones experimenting. Birds, freed from competition with flying reptiles and large predatory dinosaurs, diversified rapidly. Some lineages became specialized runners. Others returned to water. A few lost the ability to fly entirely, growing tall and heavy, filling predator roles that dinosaurs once held. These early flightless birds set the stage for later giants, creatures that would stand taller than a human and hunt with beaks instead of teeth. Reptiles tried again too. Crocodilian relatives moved into open terrestrial niches. Some became faster, longer-legged hunters, not the ambush specialists we see today. What unites all these creatures is not success, but audacity. Evolution was no longer fine-tuning. It was testing boundaries. This is the holy shit moment in evolutionary biology. Given enough ecological space, life doesn't converge on safe designs. It diverges, often toward extremes. But there's a catch. Most of these experimental lineages vanished. The question is why evolution went this far. The question is why it stopped. That's the uncomfortable truth hiding in the rock record. For every extreme form that briefly flourished after the extinction, dozens collapsed quietly, leaving behind only fragments of bone and unanswered questions. Evolution explored aggressively. Then it pulled back. Why? The answer lies in stability. The post-extinction world was chaotic. Climate swung wildly. Forests expanded and retreated. Sea levels rose and fell. In that instability, extreme designs could survive because nothing was pushing back. There were few competitors, few predators, few ecological checks, but that didn't last. As ecosystems filled in, competition returned. Food webs tightened, energy budgets mattered again. And many of those extreme adaptations, oversized bodies, hyper-specialized teeth, inefficient locomotion, became liabilities. Take those bone-crushing mammals. Crushing bone requires enormous jaw muscles, reinforced skulls, and dense teeth. All of that costs energy. In a world where prey becomes scarce or competition increases, that kind of specialization becomes dangerous. Miss a meal, and the entire system fails. Smaller, more flexible animals did better. This pattern repeats again and again. Lineages that survived long-term weren't the most extreme. They were the most adaptable, moderate body sizes, generalist diets. Brains capable of behavioral flexibility instead of purely anatomical solutions. Think about it this way. After the extinction, evolution behaved like a startup culture with unlimited funding. Wild ideas, rapid scaling, little oversight, many failures. Once the ecosystem matured, the funding dried up. Natural selection became conservative again. Here's where it gets humbling. We tend to think of evolution as progress, slowly improving organisms over time. But the post-extinction record shows something very different. Evolution is opportunistic, not visionary. It doesn't plan, it reacts. When conditions allow excess, it indulges. When conditions tighten, it cuts ruthlessly. Some of the most bizarre post-extinction animals vanished so completely that we don't even know what they ate, how they reproduced, or why they failed. Their fossil record appears briefly, sometimes for less than 1,000,000 years, then goes silent. 1,000,000 years may sound long. It is. That's shorter than the lifespan of many mammal families alive today, shorter than the time separating early humans from us. In evolutionary terms, it's a failed prototype. And yet, those failures mattered, because out of that chaos came the foundations of the modern world: placental mammals, birds with advanced cognition, predator-prey dynamics that shaped grasslands, forests, and oceans for tens of millions of years. The extremes showed what was possible. The survivors defined what was sustainable. Scientists still debate how close evolution came to paths it never took again. Were there body plans that almost stabilized, but did? Cognitive thresholds that were approached too early? Ecological roles that vanished before they could mature? We will never know. Those experiments are gone. But the lesson remains: life is not cautious by default. It becomes cautious only when forced to be. And the next time Earth experiences a true biological reset, whether from climate collapse, asteroid impact, or something else, evolution won't politely rebuild what we recognize.